Hey everyone and welcome! Today, we're going to tackle a really cool and super useful data structure from the world of computer science, the doubly linked list. It sounds complicated, but I promise by the end of this, you'll totally get it. So, let's jump right in.
So, let me ask you this. You're listening to music, right? You can always skip to the next song. Easy. But what happens when you want to go back? Or think about your web browser. You click forward, you click back. How does it know where you just were? Well, that simple little action is way more interesting than you think.
And the answer, the really elegant solution to that problem, is the doubly linked list. You can think of it as a two-way street for your data. It lets you travel in both directions, forwards and backwards, without any trouble at all.
To really get a grip on this, let's use an analogy. Imagine your data is a long train. Each piece of your data, say each song in your playlist, is a single carriage. Now, in a doubly linked list, every single carriage has a hook to the one in front of it and a hook to the one right behind it. That double connection is the absolute key to everything. It's the secret sauce.
Okay, so if we're going to understand the whole train, we have to start with just one carriage. In the lingo of computer science, we don't call it a carriage, we call it a node. So let's pop the hood and see what makes a node tick.
A node is really just the basic building block of our list. It's like a little container, and it has two main jobs. First, it holds your actual data, the song title, the website, whatever. And second, it holds those super important connections to its neighbors.
And this picture here lays it all out perfectly. See these boxes? Each one is a node, and it's got three distinct parts. Right in the middle, you have your data. In this case, just some numbers. To the right, you have the next pointer. That's the link pointing forward to the next carriage. And on the left, you've got the previous pointer, which points backward. That little previous link is what gives the doubly linked list all of its power.
All right, so we get what a node is, but how do we actually build our train? Let's walk through adding new carriages, or nodes, to our list. It's all about being really careful with how we manage those forward and backward links.
We'll kick things off with a pretty common situation. You've got your list, and you want to drop a new item right at the very beginning. You want to make it the new head of the list, or, sticking with our analogy, the new engine of the train.
Let's trace this out. So here's our new node, E. Step 1. We have to make its next pointer connect to what used to be the head, which is A. That's one connection. But we can't forget it's a two-way street. So step 2. We have to go to A and tell its previous pointer to point back to our new node, E. Once both of those links are set up, E is officially the new leader of the pack. And what's really cool is seeing how the code is basically just a recipe for the visual steps we just took. This line right here, that's us drawing the arrow forward from E to A. And this line? That's us drawing the arrow back from A to E. The code is just a very precise set of instructions for rewiring our train.
So adding to the front isn't too bad, but what if we want to do something a bit more complex? What if we need to insert a brand new node somewhere in the middle of the list? Now, this is where things get really interesting.
And this diagram shows the whole dance perfectly. We want to squeeze our new node E in between B and C. So first, we got to break that old link connecting B and C. Then we have to make 4, count them, 4 new connections. B has to point forward to E has to point back to B, E has to point forward to C, and finally C has to point back to E. It's like a little surgical procedure to insert a new carriage right in the middle of the train.
Now I know this chunk of code might look a little scary, but it's literally just doing what we just described. These first 2 lines handle connecting our new node E to the one after it, C, and the next 2 lines handle connecting E to the one that came before it, B. It's 4 lines of code for our 4 new arrows. It's a perfect, logical mapping.
So we can add carriages. What about taking one away? Let's look at how that works. Because when it comes to deleting a node, the true power of that two-way link really starts to shine. But first, to really appreciate it, let's look at a simpler one-way list. If you want to get rid of that middle node, all you have to do is change one single pointer. You just tell the node before it, hey, just skip over this guy and point to the one after him. That's it. Pretty simple.
Okay, so what's the extra step? What changes when we've got that backward-facing pointer we need to worry about?
Well, the idea is pretty much the same, but with one absolutely critical extra step. We still tell the node before to skip forward, but then we also have to go to the node after the one we're deleting and update its previous pointer to point backward, completing the bypass in both directions. You gotta patch up the road on both sides. And this is a huge deal because it means we can do this instantly without having to search the whole list to find what came before.
So now that we've seen how to add and remove nodes, we can really start to understand the pros and cons here. That extra previous pointer gives us a ton of flexibility, but it doesn't come for free. Let's wrap up by comparing the two.
Okay, here's the bottom line. With a simple, singly linked list, you can only move forward. That's it. It uses a little less memory, sure, because there's only one pointer per node. But with a doubly linked list, you get that incredible power to go backwards. This makes operations like deleting a node way more efficient. The only trade-off? A tiny bit of extra memory for that previous pointer on every single node. It's a small price to pay for a whole lot of power.
So, to quickly recap, doubly linked list, it's all about the two-way street. Every single node knows what's in front of it and what's behind it. This is what lets you move back and forth so easily. Yeah, adding and removing nodes takes some careful pointer surgery, but what you get in return is a data structure that's just way more flexible and powerful.
So there you have it. You now have the blueprint for this amazing data structure. And once you start looking for it, you'll see it everywhere. That undo and redo feature in your text editor, the timeline and video editing software, a music player's queue, they all benefit from this power to move in two directions. So the real question is, now that you know how it works, what would you build with it?